tracing system with the heat loss from the insulation surface to the ambient. This guarantees that the inside stays at the same temperature. Cold insulation is the same as economic factor. Quite often there is a maximum permissible heat gain to the system. If more heat gets into the system and you're insulating refrigerant systems, the boil-off increases, which is not desired. And then we have to make sure that the insulation does not get wet, it's not too cold at the surface and condenses the air humidity. It's also called sweating. Personal protection, there are no economics involved. It is only, you only have to determine a temperature that is safe to touch, or a thickness that results in a temperature that is safe to touch. I think it's currently about 140 degrees F. Acoustic insulation, we use typically two grades, which give us about 10 dB attenuation or 15 dB attenuation. And again, if you use thicker insulation, the insulation gets more effective at lower frequencies. Then we have to select the weather jacket. Most insulation uses aluminum worldwide. In some cases, we use stainless steel if aluminum is not suitable, or if we need some fire safety. Acoustical insulation is a special jacket required normally, which is aluminum jacket laminated to a mass-filled vinyl, and these things come up to 2 pounds per square foot. Here are some of our client specifications. As you can see, Chevron prefers calcium silicate for hot insulation. On the other hand, Shell does not want to use calcium below 500 degrees F. CNL prefers mineral wool up to 450 degrees. Above this temperature, they prefer a calcium silicate. BP specifies calcil indoors and perlite outdoors. Can you click on the Chevron insulation material table? This is Chevron's listing of possible materials by generic type, commercial brands. The insulation value or K factor, compressive strength, and density gives us again a guide how to select materials. Go back, please. Can you click on PIP? This is an insulation standard, a system to develop specifications. They're kind of generic, and you build your own specifications the way you need it for your project. Very flexible, and they go into big detail. Can you show some pictures down there? They tell for each item how to insulate in regard to how you put the wires on the bending, the jacketing, everything is specified here. This makes it easy for us to control our contractors if they know exactly how this is done. This is in addition to the verbiage in our specifications. And this covers almost every item you can think of in a refinery. Click. We also get from our client other instruction. Can you click on Chevron tank insulation? So here is, in addition to the specification, they give us detailed instructions how to do the insulation in big detail. So it's almost impossible to do things wrong. Okay. And this is for piping, for cold insulation, all kinds of things. Can you click on BP insulation materials table? This is a simple table BP uses for the North Slope installation to tell you what material can be used indoor and outdoors and at what temperature ranges. Okay. In general, We paint under insulation to prevent corrosion, only to a certain temperature. We put a weather jacket on the insulation to keep it dry. Insulation thickness, we talked about how we determine this. There's especially items like flange and welds we have to insulate with special covers quite frequently. We're also preparing on most projects insulation schedules for piping and equipment that tells the contractor exactly how to insulate and what to insulate. Click on cold insulation. Here's a little example from the North Slope. The lower heat exchanger on the left-hand side is insulated with cold insulation. The rest is not. The reason was that the heat gain here is immaterial to the process on this side. However, they learned later on that ice builds up in the wintertime to a very thick layer, and when the weather changes, this ice comes down in big sheets and became dangerous. So I think in the future they might want to insulate this. Click again. Quite often we work overseas and we're not sure that our contractors are able to do the installation right. Click on Village Pipe, for example. Yeah, this one is good. So we ask them to supply their own drawings or sketches how they do the installation. You can see here all the details, number of layers, expansion joints, and then all these little numbers point to the materials you plan to use. This is a good tool for us to make sure he understands the scope and can do it right. Okay, the column on top right, please. This is the biggest column I got involved in insulating. I think it's 110 meters tall, 8 meters in diameter. It has cold insulation with foam glass, and it was done in the horizontal position and is now erected. And the task here was to make sure the insulation stays in place during this change of position. It's worked just fine. Okay. I think this was for our insulation. Now we go over to refractory. These are high temperature linings which are used inside equipment mainly. These are ceramic materials in different forms and shapes. They go to temperature up to 3,000 degrees or even higher in some cases. And here's a list of typical equipment which are lined. And the reason for lining them is protection of the outer shell, so you can use less expensive materials. It's done to reduce the temperature to an acceptable temperature. Once in a while we use refractory lining to prevent that the process gas comes in contact with the steel and can cause high temperature corrosion. And there are cases where we have only to protect against erosion. Refractory comes in blankets, in castable ceramic mixes and bricks in special shapes. Here is a ceramic fiber module which is used to protect heater casings. Can you run the fiber movie? Here's a little movie how it's done.
Thermal Ceramics manufactures a complete line of ceramic fiber module systems that are easy to design and install. Our innovative PyroBlock module, a monolithic insulating block manufactured in our operation in Emporia, Kansas, is based on a fiber log that is 40 feet long by 6 inches thick. To make the completed PyroBlock modules, we cut the pyro logs, turn them edge grain, and insert the specially designed hardware. PyroBlock EES modules used for electric element kilns feature heating elements secured to the modules by ceramic supports suspended from ceramic tubes within the modules. In addition to well-bound modules made from the monolithic Pyrolog fiber, Thermal Ceramics manufactures an accordion-folded blanket module called PyroFold and a stacked edge-grain blanket module called PyroStack, each of which also uses the PyroBlock hardware and anchoring system. The Pyro family of modules are available in alumina silica, zirconia added, or chrome-containing compositions, and two anchoring systems, Y and M, depending on whether a pre-laid-out scuff pattern or corrosion barrier is needed.
Castables are mainly used for cast in place or pneumatic placement. Occasionally we have to apply the lining by hand packing. And we can categorize castable in many ways: type of placement, cement contact and use, density, type of bonding. And here's an example how they are called in catalogs and vendor data. There is a special type of castable which is called a ceramic mix. It's called also plastic. These come in the final form like a brick, and you place them in the area you want to use them and pound them into place with a pneumatic hammer. Bricks are used in our class units extensively. These linings go up to 3,000 degrees in reducing atmospheres, which is a very severe exposure. Can you run the brick movie?
Thermal Ceramics has been the market leader for insulating firebrick for more than 60 years. The lower temperature grades K20 through K26 are individually manufactured by our unique slurry casting operation. We then wire each cast brick in a new precision-controlled tunnel kiln and or over its use limit temperature. This guarantees proper heat treatment and ceramic bonding throughout the brick, resulting in high hot springs and low shrinkage of surface. After firing, these bricks are machined to precise dimensions by processing through a series of grinding wheels. The IFB can be custom ground or ordered into mill-up shapes to meet specific customer requirements. The higher temperature brick grades TC26 through GM30 are made by a continuous slab forming process. A ceramic bond is formed during high temperature firing, and they are cut to final brick size. This process produces high temperature insulating firebrick that are both dimensionally accurate and thermally stable at temperatures up to 3,000 degrees Fahrenheit.
And these bricks we use in the backup lining behind this hot face lining. Click on pictures. Here you see insulation in progress. The lining is applied in rings which have to be supported individually until the ring is completed, and you put the keystone in the top position. This will be the keystone from the previous ring here. Once the keystone is in, you can remove the supports and the ring is stable. We are using plastic. This is plastic ramped in place castable. Or we can drill from the outside through the entire lining to have an opening. Here is the incoming line where we use what we call a bullseye construction. It's very sophisticated bricklaying, and I think the bricklayers are the highest paid trade in this field. The high alumina bricks we use for the hot face lining are very dense, have almost no insulation value, but they can take the abuse of the process, gas and temperature. Here are some special parts we use in our installations. On the left-hand side, there's a checker wall we used in Bakersfield for a small Klaus unit. This was cast by a local contractor and then fired to 3,000 degrees and will be installed as a finished fired piece in the unit. On the right-hand side, there are ferrules which are used for the waste heat boiler tube inlets to protect the tube sheet from the radiant heat of the reaction furnace. Can you run the special parts movie? Here's the way it's done in the shop.
To meet our customers' needs for precisely manufactured fired ceramic shapes, Thermal Ceramics produces a line of slip-cast aluminum silica, high alumina, and aluminum silica zirconia composition. Custom-made parts are designed to individual requirements in a wide variety of shapes and sizes. The method by which Xerox and Califor parts are made is more of an art than standard industrial processes. Expertly constructed hard plaster molds are filled with thixotropic ceramic mix, which becomes more fluid when energy is applied. Then vibrated so that the material takes the exact shape of the mold cavity. The castings are then dried and fired using a long high-temperature cycle that produces strong shapes resistant to chemical attack and crack. Each finished piece is individually inspected before shipping.
We use these shapes at special location in the reaction furnace. The design of the system has to consider the temperature, of course, the corrosion and the erosion. Can you show this erosion-resistant lining, please? This shows a lining that has no thermal value, only erosion resistance. We are applying a hex mesh, here's a sample of it, to the shell of the equipment, and this is welded into place, and then it's filled with a high-performance ceramic material, which is excellent to resist erosion. Anchors, please. Castable linings are attached to the shell with anchors, which are placed on a certain pattern on the shell. In this case, the client tells us exactly how to do it and where to do it, how to weld them. So again, we're using client specifications. Thank you. Many linings have a multi-layer system, and in this case, you have to check that the temperature profile across the layers is acceptable. Can you click on temperature profile, please? So, depending on the insulation value of each layer, you get a different steepness in the graph, and we have to make sure that this temperature is not too high for the second layer, and that these temperatures are acceptable. We have to check the system for integrity. The system have expansion and contraction, and stress is caused by this expansion and contraction. We have to make sure that we don't overstress the material. Frequently we use our own specification. Please click on this on the link. Can you go down to the ASTM standards? Just to give you an impression here, this is the standards which are involved in inspecting these materials, quite extensive. Go further down. Then we are specifying to the contractor what he has to do, what we expect of him in regard to details of the installation. Go further down. We specify the materials furthermore next to the next table, please. Further down. Here we specify the materials to be used in generic types, and then we Go further down. We specify the physical properties for these materials further down. No, stop here. This is where we tell the contractor what goes where. Each item to be lined is listed here, and which component has to be lined and how to line it, thickness and type of material further down. Can you go down more? Here we specify the properties of the materials we expect the materials to have. And go down to the end. In some cases we have to add little sketches or drawings to show details of the installation where it's critical. Here, for example, we show the little further up, little up. Can you go a little higher? Yeah, here we show the connection between the reaction furnace wall and the boiler tube sheet. Here are some typical examples. This is a reaction furnace. There's the two linings, the backup lining, the hot phase lining. Here's a choke ring, which is used for better mixing, and here is a tube sheet lining with the ferrules in the tube sheet. This is a unit that uses extensively refractories almost everywhere, all kinds of refractories. It has a reducing atmosphere in this piece of equipment. Here is a riser which sees severe erosion, so do the cyclones here. So everything you see here is refractory lined basically. This is another piece of equipment where you have a lining inside a lining. This was our section on refractory, and now we go to passive fire protection. We are only involved in specifying the materials to be used. We don't get involved in the extent of the fireproofing. This is done by Mechanical Utilities Group. But fire protection is only one component of the overall protection scheme, and it only protects against hydrocarbon pool fires. You cannot protect against any gas explosion or gas fires with fireproofing. It's strictly for hydrocarbon pool fires. The extent of the fireproofing is determined through a fire hazard analysis, which we don't do, and this identifies fire potential equipment, and this leads to a fire scenario development and arrives at a fire scenario envelope and a need list. Typically all structural steel or vessel supports which are located in this fire scenario envelope require fireproofing. The fireproofing is based on a fire resistance rating. You determine how many hours you expect the steel has to last in a fire case. And can you click on XR 180? This rating is material specific and is certification by Underwriters Laboratory based on a UL 1709 test. And this tells you exactly how to apply the materials to get this rating. And you determine, let's say you want to have a 3-hour rating, you need to apply 0.6, I think, inches of this material to get the 3-hour rating. Typically, the radial and vertical distances from fire equipment are specified in API 2218. And go please to this table that shows first of all, here is a sequence how you arrive at the fireproofing needs for a unit. Go further down. And stop. And this is here is typical dimensions for the fire scenario envelope. Everything that falls into this area is typically fireproofed. Okay, we can quit this. We fireproof typically structural steel that supports equipment, and vessel, skirts, and settle. Click on the link, please, on the fireproofing picture. Oh, it's bad, bad, bad. But this structure is only partial fireproofed, but you can see that the entire column here is fireproofed up to the top, and the cross members are fireproofed here. Oops. They are fireproofed because this equipment up on top here and here is fire potential equipment. However, these platforms here are not needed in the fire case to keep the integrity of the structure. Some is too thick. Therefore, it's not fireproofed. Occasionally, we also have to fireproof cable trays if they have vital cables on them which are required for the shutdown process in an emergency. Also, sometimes you have to fireproof shutdown valves and actuators. Fireproofing can be done in many ways. The old-fashioned way is old good concrete, about 2.5 inches thick, which is cast around the structural members and performs really marvelous in a fire. Recently, we also used lightweight concrete, which is a mix of concrete with some vermiculite in it. As there are other materials with low thermal conductivity. Some are ablative, some are subliming. These materials all reduce the rate at which the steel can heat up during a fire. Typically, the steel can heat up to about 1,000 degrees before it becomes unsafe. There are some specialty materials like intumescent epoxy, which is applied like a paint. If it gets into a fire, it puffs up into a thick layer, maybe 2 inches thick, and provides the protection. And all these materials will only work for a short time period, typically in refineries 2 to 3 hours. This curve shows how steel loses its strength with temperature. If we go to our 1,000 degrees here, we have about half the strength left, which is typically safe. Here are some brand names. Proprietary materials are pyrocrete, phenolite. These are water of hydration plasters which use crystalline water in the material to be released during a fire. There are subliming materials which convert from solid to gas and using thereby heat. Intumescent materials, they puff up and form a passive layer in a fire. And this was it.
Some of the fireproofing is does some of it need to be explosion proof?
Fireproofing is not explosion proof. If you have an explosion, the fireproofing flies away with the structural steel. It only protects if you have a hydrocarbon pool fire and the steel is affected by radiation or directly in the flames. This is the only protection you have.